Probability of not, or, and odds. We're going to talk more about or here. This is part 2 of 11.6. Suppose we have a group of people that consists of 10 male professors, 12 female professors, 8 male TAs, and 6 female TAs. These problems are best worked by making a chart. And so we can have prof and teaching assistant on top, female, male on the side. 10 male professors, that's going to go right here. And 12 female professors, that's right here. Okay, let's darken that a little bit. 8 male TAs, that's 8. And altogether 6 female TAs, so we'll make this 6. It's convenient for purposes later. You can add this up. 12 and 6 is 18. 10 and 8 is 18. 12 and 10 is 22. 6 and 8 is 24. Or 14, sorry about that. If you add these up, 22 and 14 is 36. 18 and 18 is 36. So we have 36 total. That'll be useful. I want to find the probability of, so we select one person and want to find the probability of selecting a prof or a female. There's an interesting formula we can illustrate here. You'll probably make more use of this if you take college statistics. If it's or probability of professor plus probability female, minus probability of professor and female. Let's see how this works. Probability of a professor, guess what? There are 22 of them. 12 and 10 is 22. Is 22 out of 36. Probability of selecting a female is 12 and 6 is 18. Now, what's the probability that it's professor and female? Let's see, professor, that's this right here. So we have to subtract out 12 out of 36. Well, you can add it up. 22 and 18 is 40. 40 minus 12 is 28 out of 36. You could actually calculate this directly. This is a good problem to illustrate this formula. Professor or female. Here's the professors. Here's the females. You notice what happened when we added them up. The 22 was 12 and 10. The 18 was 12 and 6. How many times did I say the word 12? I said the word 12 twice. These people got added in twice because the sets overlap. This way we have to subtract it out. We could calculate this directly. We equally as well could have just said 10 plus 12 plus 6. Circle it and add up the compartments, and guess what? 10 plus 12 plus 6 over 36 adds up to be the same thing, 1828 out of 36. When this thing here is not empty, these events are not mutually exclusive. So for instance, if it's a professor, it could be a female. If it's a female, it could be a professor. Okay. In the case where we have mutually exclusive events, we'll talk about an example in a minute. You really don't need this term here because it's 0. Let's suppose we wanted probability of male or female. Now in this case, the way this table is set up, they are mutually exclusive. We assume that a person's in one category or the other. There could be some blending of these categories, but we're really not interested in that for the sake of probability at this point. So male or female, that's simply going to be probability of male plus probability of female. What's the probability of a male? 18 out of 36. And probability of female is 18 out of 36. And altogether we get 36 out of 36. Okay, there's no categories for here for a person being in both categories. So we don't need that extra term. You can put that extra term here, and we'd end up subtracting out 0. In this case, the way this chart is presented, these two things are mutually exclusive. Okay, events are mutually exclusive when one thing happening excludes the other and vice versa. So for instance, you're flipping a coin, heads and tails are mutually exclusive. Drawing a card out of a deck, a 2 or a 3 is mutually exclusive. Or clubs and spades, those are mutually exclusive. If it's a club, it's not a spade. If it's a spade, it's not a club, simply put. Okay? That's all for this video.